Time is the one thing we all feel intimately, yet it remains utterly mysterious. We live our whole lives within time's flow. We measure it with ticking clocks and changing seasons. But when physicists peer closely at the nature of time, it starts to look as if our familiar flow of moments might be an illusion. We remember yesterday, but not tomorrow. We feel time pressing onward, never backward. Why is that? Why does time seem to speed up when life is good and slow down in moments of crisis? Is time a fundamental part of reality, or is it something our minds create? These gentle questions whisper to us as night falls. So tonight, under the quiet stars and the soft sound of rain, let's explore the secret life of time, slowly, calmly, like a dream we don't want to wake from. Together, we will drift through the mysteries of time, unhurried and curious, comforted by the vast, starry backdrop against which our lives unfold. Relax, and let's begin this journey through time's deep secrets, one gentle step at a time. Time feels so real to us. We plan our days by it, cherish memories of the past, and look toward the future. And for much of history, we assumed time really was this universal, reliable background ticking along. Sir Isaac Newton imagined time as absolute and unchanging, flowing at a constant rate everywhere in the universe. In Newton's view, time was like a giant stage on which events played out, a steady drumbeat that every clock in the cosmos ultimately followed. This idea of absolute time made sense. It certainly feels like there's a single cosmic clock. But in the 20th century, Albert Einstein gently upended this comforting picture. His theories of relativity suggested that time is not absolute at all. It can stretch and bend, running slower or faster depending on speed and gravity. What we call time is woven together with space into a four-dimensional fabric, and this fabric warps in the presence of mass or at high velocities. The result is astonishing. There is no single universal time. Your time and my time might not perfectly agree if we move differently or sit at different heights in a gravitational field. Einstein's relativistic universe is almost like a dream where each dreamer has their own clock. If you fly in a fast jet or live on a mountaintop, time will pass just a little differently for you than for someone on the ground. In 1971, scientists carried atomic clocks on around-the-world flights to test this, and when the clocks returned, they no longer matched the ones left on the ground. The moving clocks had ticked a tiny bit slower, exactly as Einstein predicted. Even gravity makes a difference. A clock raised high above Earth ticks slightly faster than one at sea level, because time itself runs faster where gravity is weaker. We don't notice these effects in daily life. They're incredibly small, but they are very real. For example, the GPS satellites guiding you home must account for these relativistic quirks. Their onboard clocks tick ahead by a few millionths of a second each day, due to their high-speed orbit and the weaker gravity above Earth. Engineers actually adjust the satellite's time, subtracting and adding tiny amounts, so that GPS stays accurate. Imagine, if they didn't, the whole system would drift off, and your GPS map could be off by miles. All because, high above us, time runs just a touch faster than it does down here. Such findings fill one with a kind of quiet wonder. Time, which felt so solid and uniform, is pliable. Two twins could be born together and meet years later to find one slightly older than the other, simply because one travelled fast in a rocket or lived at a lower gravity than the other. Our common sense idea of a single ticking clock for the universe has melted away. In its place, Einstein gave us a vision of spacetime, a unified expanse where space and time blend, and the straight segments of Newton's time can curve. If you could move near the speed of light or hover by a black hole, your now might include someone else's future or past. It's a strange, shape-shifting theatre. Yet despite this strangeness, it's also comforting in a way. The laws of nature keep time and space in balance, so that cause and effect still make sense. Even if two observers disagree on the duration of an event, they will agree on what causes came before which effects. Relativity may say time is flexible, but it doesn't turn reality into complete nonsense. It merely invites us to broaden our perspective. The flow of time is part of something bigger and more complex, but it's not broken. It's different from what we first believed. So physics tells us time can twist and stretch, but what about how we experience time?
Here in our everyday lives, time shows us yet more of its secret faces.
In our minds, an hour can fly by, or it can crawl, depending on how we spend it. A quiet afternoon with friends might blink by in an instant, while a short wait in a dentist's office feels endless. As children, we all felt the long, languid days of summer that seem to last forever. But as we grow older, the years begin to rush past more quickly each time we blink. This isn't just imagination. Psychologists say it's a known effect of memory and perspective. When you're 8 years old, a single year is a huge portion of your life's experience. To an 80-year-old, 1 year is a much smaller slice of life, and often a more routine one. The older brain has seen many of the same patterns before, so it records fewer new memories. With fewer unique reference points to distinguish moments, whole weeks or months can blur together in retrospect. As one neuroscientist put it, when you're a child, you lay down rich, dense memories for every new experience. When you're older, you've seen it all before and form fewer memories. And the more memory you have of an event, the longer you believe it took. So a summer in childhood feels vast in memory because it was packed with novel moments. In later adulthood, a year can seem to evaporate, each day so similar to the last that our mind compresses them. It's poignant, but it also teaches us something. To slow time in life, maybe we must seek new experiences, pay closer attention, and effectively create more frames in the movie of our memory. Time in the mind is wonderfully malleable. Think of how differently time flows in a dream. We close our eyes for what might be minutes, and yet we experience a dream that seems to span hours or days. Other times we wake and feel we barely dreamed at all, when in fact the REM phases cycled through the night. In dreams, the normal rules of time are loosened, a kind of internal cinema where scenes can jump or stretch without regard to the clock. And consider those rare, timeless moments in waking life, perhaps during meditation, or watching a magnificent sunset, or when you're in the zone, creating art or playing music. In those moments, you lose the sense of time passing entirely. You look up, and an hour has gone by in what felt like a blink. Psychologists call this flow, total absorption where self and time fade away. It's a peaceful state, almost a small nirvana, where we exist purely in the experience. On the flip side, time can also drag painfully. Everyone has felt the minutes snail forward in a tedious meeting or a classroom on a dull day. And in extreme situations, our minds can stretch time in ways that feel nearly supernatural. People who have been in danger often describe something extraordinary. During a car crash, a fall, or another life-threatening moment, time seemed to slow down dramatically. A second felt like 10. The world moved in molasses. They could notice absurdly fine details as the event unfolded. It's as if the brain switched to high-speed recording, and later the memory plays back in slow motion. Scientists have studied this by dropping volunteers in free fall and measuring their perception. The surprising result is that our brains probably don't speed up in real time. Instead, the amygdala, our fear center, lays down extra vivid memories during frightening incidents. When we recall the event, there are so many memory details that it feels as if it must have taken longer. In essence, time in our memory stretches out. The slow motion effect is a kind of retrospective illusion. Our subjective timeline expands because we captured more impressions. And interestingly, this is related to the time speeds up as we age phenomenon described earlier. When you're young or in a novel situation, you're recording rich memories, so later it seems like time was slower and fuller. When you're older or in routine, fewer memories are stored, so looking back, whole years seem like brief blurs. Our brains are time machines in their own way, warping and stretching the seconds according to attention, emotion, novelty. Time lives in our minds as much as in the outside world. Yet, beyond these mind-bending perceptions, there remains a fundamental direction to time that dominates our reality. No matter how slow or fast time feels, we inexorably move from past to future. We all grow older, never younger. We remember yesterday, but not tomorrow. This one-way arrow of time is one of the deepest features of our experience, and of the universe itself. Why does time seemingly flow forward and not backward? Physics tells us the answer lies in entropy, a measure of disorder. The second law of thermodynamics says that in any closed system, entropy tends to increase over time, not decrease. In simpler terms, things fall apart. They don't spontaneously put themselves back together. If you drop a ceramic mug, it shatters into pieces on the floor, and those pieces will never magically leap up and reassemble into the original mug. That broken mug scenario distinguishes past from future. A video of the mug breaking looks normal when played forward, intact mug to pieces, but absurd in reverse. In the reversed version, chaos, shards, would be spontaneously organizing into order, a whole mug, and that just doesn't happen in our universe. Almost all fundamental physical laws are actually symmetric in time, meaning at the microscopic level, interactions can often run backward just as validly as forward. What then enforces the arrow of time we observe? It turns out to be the initial conditions of our universe. The universe began in a state of very low entropy, high order, and has been increasing in entropy ever since. This universal trend toward greater disorder is what gives time its arrow. It's always the direction toward more entropy. Every broken cup, every melted ice cube, every instance of eggs scrambling but never unscrambling is a reflection of this arrow. We can tell the forward direction of time because that's the direction in which entropy grows. And this has deep consequences. It's why we have memory. We remember the low entropy past, but not the higher entropy future. And why we feel we can affect the future, but not the past. The arrow of time is responsible for the fact that we grow older, our bodies gradually move toward more disordered states, and that stars burn their fuel, gradually increasing entropy in the cosmos. It gives a kind of melancholy cast to existence. All things change, structures eventually decay. But there's comfort in it too. The forward flow of time is intimately tied to life and growth. Babies become children, then adults. Experiences accumulate. The present builds upon the ordered memories of the past. In a universe without an arrow of time, nothing would happen in any meaningful sense. Because of entropy's arrow, our universe has a narrative, a past, a present, a future. Cups break, but that allows new things to be created from the pieces. Stars exhaust themselves, but in doing so they forge heavy elements that seed new stars and planets. Time's one-way street can be bittersweet, yet it is also what gives meaning to moments. Each moment comes only once. Each now is special because it will never come again. That knowledge can fill us with a gentle sadness, but also with gratitude. Now, let's drift deeper, to the realm of the very small and the very strange, where time behaves in ways that challenge our intuition even more. In the quantum world, the world of subatomic particles and wave functions, time as we know it almost seems to lose its grip. The fundamental equations of quantum mechanics, like Schrödinger's equation, don't actually distinguish past from future. They are mostly time-symmetric, much like most classical laws. At the tiniest scales, a particle's behavior sometimes appears to blur the line of before and after. For example, in certain experiments in quantum physics, we find that the order of events can become ambiguous. In a famous delayed choice experiment, a particle, like a photon, seems to decide whether it behaved like a wave or a particle after it has already passed through a double-slit setup, as if a future measurement influenced its past behavior. While in truth no information is travelling backwards, so causality is safe, these experiments reveal a quantum reality where the sequence of events is not as straightforward as our normal experience of time. Cause and effect can get fuzzy at the quantum level. It's as if the concept of a definite before and after is partly an emergent thing that only solidifies at larger scales or when observed. Even more startling, when physicists try to merge quantum mechanics with general relativity, Einstein's theory of gravity, they encounter the so-called problem of time. In general relativity, time is dynamic, part of the space-time fabric that can stretch. In quantum mechanics, time is often treated as a fixed background parameter. How do we reconcile the two? One leading approach to quantum gravity, the Wheeler-DeWitt equation, essentially removes time altogether. In this theoretical equation, which attempts to describe the quantum state of the entire universe, there is no variable for time as we know it. As physicist Carlo Rovelli explains, time just disappears from the fundamental description of the universe. What could that mean? One interpretation is that, at the deepest level, the universe just is, a static quantum state, and what we perceive as the flow of time is something like an emergent illusion that arises only for internal observers, like us, within that state. This is a mind-bending idea, that the universe, in its entirety, might be timeless, and time appears only because we, internal to the universe, experience things in sequence. It's as if the universe were a book already written, and we are characters reading it page by page, feeling the flow, unaware that the whole story might already exist in some sense. In this view, the apparent passage of time might be similar to how temperature emerges from a bunch of moving particles. Temperature isn't a fundamental thing on its own. It's a measure of the motion of particles. Likewise, perhaps time is not fundamental, but arises from the relations between quantum states. To test such ideas, scientists look for ways that time might be an emergent phenomenon. Rovelli and others have suggested models where, instead of time-driving events, the universe can be described by how things change in relation to one another, without reference to an external clock. Instead of saying particle A changed at time t, one might say particle A changed whenever particle B's state reached a certain value, eliminating an outside time parameter. From this perspective, what we call time is a convenient story, a way to map the interconnected changes in the universe onto a single axis. It's a radically different way to think, and it's far from proven, but it carries a quiet, mystical allure. The world we experience, with a flowing time, might be like a mosaic emerging from a timeless substrate. Perhaps only things with many particles, or complex states, like conscious brains, feel time. Below that, at the Planck scale, the tiniest scale of length and time, where quantum gravity reigns, our familiar concept of time might break down entirely. At that scale, trillionths of a trillionth of a trillionth of a second, the distinction between before and after may become meaningless. Time and space might dissolve into something quantum and strange. Gazing back, we've followed time from the human scale to the quantum, and now it's time to zoom out to the grandest scale of all, the cosmos's beginning and its possible end. Our universe has a birthday, so to speak. The moment of the Big Bang, about 13.8 billion years ago, when space and time as we know them came into being. It's often said that asking what happened before the Big Bang is meaningless, because time itself may have begun with the Big Bang. It's a hard concept to wrap our heads around. We are time-bound creatures, and the notion of no time is as hard to imagine as the edge of the universe. But what we do know is that in the earliest fractions of a second after the Big Bang, the universe expanded with astonishing speed. Cosmologists call this brief era inflation. In far less than a blink, on the order of a tiny fraction of a second, space itself swelled enormously, doubling in scale over and over, exponentially. During this inflationary burst, the universe was a hot, dense fog of energy. When inflation stopped, that vacuum energy poured into creating matter and heating the universe in a flash. The hot Big Bang proper began as a result. Picture it. 1 second after the Big Bang, the entire universe was an extremely hot soup of particles and light. Imagine all of space filled with a glowing plasma nearly 10 billion degrees hot, so dense that in every tiny volume, countless particles collided. Time, in those first seconds and minutes, was marked by monumental milestones in the universe's composition. Within the first few minutes, as the fireball cooled a bit, protons and neutrons began combining into the first atomic nuclei. By about 5 minutes in, the nuclei of hydrogen and helium, and a dash of lithium, had formed. The universe was still an opaque glow, a brilliant fog of charged particles and photons scattering off each other. As the expanding cosmos stretched and cooled over thousands of years, it took until roughly 380,000 years after the Big Bang for electrons to slow down enough to combine with those nuclei and form the first neutral atoms. When that happened, the fog finally lifted. Light could travel freely for the first time. That light, the cosmic microwave background, still faintly glows today, a relic snapshot of the universe at the moment it became transparent. Time had allowed structure to emerge from chaos. From the uniform glow, slight density variations, tiny wrinkles left from inflation, meant some regions would eventually coalesce into galaxies and stars. Over billions of years, under the direction of time and gravity, the cosmos blossomed. Galaxies swirled into being, stars were born, lived and died, and planets formed. On at least one small planet, life began and grew aware of time's passage, marking calendars and wondering about the past and future. It's a grand cosmic timeline, from a hot, nearly timeless plasma to the intricate world we know. But will time ever end? The story of the universe isn't finished, and how it continues, and perhaps concludes, is another profound mystery. Scientists have several scenarios for the ultimate fate of the universe, and each carries its own implications for time. The most widely accepted idea is the so-called heat death, or big freeze. In this scenario, the universe keeps expanding forever. Over incomprehensible spans of time, galaxies accelerate away from each other, stars within them burn out, and new stars stop forming. Bit by bit, Lights wink out across the cosmos. The universe approaches a state of perfect disorder and extremely low temperature, asymptotically nearing absolute zero. All processes that consume usable energy wind down. In a sense, time would still march on, but in a heat-dead universe, nothing of interest happens. It's almost a philosophical question whether time means much when the state of everything is unchanging. Trillions of years from now, if this fate holds, an observer, if any could exist, would see nothing but the faint afterglow of black holes evaporating and particles decaying, spread thinly across a dark, cold cosmos. The arrow of time would have run its course by reaching maximal entropy, basically a still, silent eternity. It's a rather melancholic prospect, the cosmos dying not with a bang, but with a whisper as time stretches on into near nothingness. Another possibility is more dramatic, the Big Rip. In this scenario, the mysterious dark energy that is making the universe's expansion accelerate grows in strength over time. Instead of a gentle acceleration to a quiet end, the expansion becomes runaway. Eons from now, galaxies would first be pulled apart from each other. Then, gravity would no longer hold individual galaxies intact. Solar systems would fly apart. Eventually, even planets, stars, and atoms might be torn to pieces by the ever-increasing expansion of space. This would all happen in a finite amount of time, literally ending in a singularity of infinite expansion rate at some point. If the Big Rip is our fate, time for the universe would culminate in a final, violent schism, where every structure is sundered. It's a terrifying idea on the face of it, though current observations suggest if it were to happen at all, it would be far, far in the future, tens of billions of years or more. Under the Big Rip, one could say the arrow of time meets a sharp, literal tearing end, after which no clock could really function when even atomic rhythms are destroyed. There is also the classical possibility that enchanted earlier generations of astronomers, the Big Crunch. If, contrary to current evidence, the combined gravity of all matter, and perhaps some change in dark energy, caused the expansion of the universe to reverse, then the cosmos could stop expanding and begin to contract in the far future. Galaxies would hurtle back together. Over billions of years, distances would shrink. Temperatures would rise as everything crowds in. Eventually, perhaps, all matter and space would collapse into a final singularity, not unlike the Big Bang in reverse. Time, in a big crunch, would still move forward. Entropy would increase as things collapse, but one could imagine it as the mirror image of the beginning, a great convergence of everything. Some have wondered, could that final singularity trigger another Big Bang, a bounce, starting a new universe? That leads to the idea of a cyclic universe, an endless series of universes expanding and contracting, reborn each time like a phoenix. In a cyclic model, time would be circular in a grand sense, no absolute beginning or end, just an eternal rhythm of cosmic breaths. One universe's Big Crunch is the next universe's Big Bang. Such models are speculative, and there are issues. For instance, entropy would build up with each cycle, which is hard to reconcile unless new physics resets it somehow. But it's a haunting idea. Perhaps time is not a line, but a loop, the end folding into the beginning. If that were true, time truly would be eternal, though we, in this incarnation of the cosmos, would never know it, as we're confined to our cycle. So the universe's far future might be heat death, or a rip, or a crunch and rebirth, or something even stranger. Some hypothesize vacuum decay, where a quantum transition could radically remake reality in an instant, but that's a very remote hypothetical. Whatever the fate, It lies so far ahead that our human minds can scarcely grasp the scales. The death of the last star under even the heat death scenario won't occur for trillions of years. By comparison, the universe today, at approximately 13.8 billion years old, is like an infant. Time without us will continue to unfold. And that brings a humbling realization. Our entire civilization, our species, even the Earth itself, are momentary flashes in the universe's timeline. We have appeared in the cosmic story just for a brief chapter. Imagine future eons where humanity is long gone, perhaps having evolved into something else or gone extinct, and yet time goes on. Stars will continue to be born and die. In about 4 to 5 billion years, our own Milky Way galaxy is on course to collide and merge with the neighbouring Andromeda galaxy. The night sky would change over millions of years as Andromeda's stars mingle with ours, a majestic slow-motion dance of creation and destruction. By around that same time, our Sun will have exhausted the hydrogen in its core and swollen into a red giant star, likely swallowing Mercury and Venus, and perhaps even the Earth itself. Long before the Sun's actual engulfing of Earth, the increasing solar heat will boil away our oceans and strip Earth of life. But this too is part of time's flow. Stars like the Sun have life cycles, and ours is roughly halfway through its serene fuse. We happen to be here now, alive at an auspicious time when the Earth is warm and habitable. This will not always be the case, but that is all right. Maybe by then, if intelligent life still exists, it will have found new homes among the stars. And even if not, the atoms that make up our bodies will be returned to the cosmos to someday join new worlds or float in the interstellar night. When we pull back and view the cosmic calendar, we see how tiny our moment is. If the history of the universe were compressed into 1 year, all of human history would fit in the last few seconds of December 31st. Time without us has been vast, and will be vast. But that doesn't make our time insignificant. In fact, it makes it precious. We have our little window to look at the universe and marvel. The stars will continue to age for billions of years after we're gone. New stars will be born from old stars' ashes. Galaxies will drift and merge. Perhaps in some far-flung galaxy, other beings will walk under alien skies and wonder about time and mortality as we do. We are part of this grand story, a very small part, but an integral one. The universe has grown aware of itself through our eyes and minds, even if briefly. We should feel humbled, but also connected. All these scientific truths and theories, relativity, entropy, quantum timelessness, cosmic time segments, paint a picture of time that is far from simple. And they invite perhaps the deepest question of all. Is time truly real? Or is it an illusion crafted by our perception? This is not a new question. Philosophers throughout the ages have pondered it. In modern physics, one view, often called eternalism or the block universe idea, holds that time might be like space. All of it exists, and the flow we feel is a kind of perspective effect. In a four-dimensional block universe, the past, present, and future are equally real, just as here and there are equally real in space. We happen to perceive now at a certain slice of this space-time, the way an ant crawling along a map perceives only the point it's at. Einstein, in consoling a friend's widow, famously wrote that for those of us who understand physics, the distinction between past, present, and future is a stubbornly persistent illusion. He wasn't saying that events don't happen, or that we can walk into yesterday. Rather, from the standpoint of relativity, what one observer calls the present might be in another's future or past. All moments exist in the fabric of space-time. The flow is in the eye of the beholder. It's a very strange idea, almost spiritual in implication. It suggests that in some sense, our lost loved ones, our past selves, all still exist in their particular slice of space-time, just not accessible to us now. Some physicists and philosophers take this very seriously, arguing that the flow of time is a subjective product of consciousness, and that objectively, the universe simply is, with time as another dimension. Then there's the possibility that our reality is not fundamental at all, the so-called simulation hypothesis. If our universe were a simulated reality run on some vast cosmic computer, then what is time to the simulator? Likely just a variable in a program, a parameter that can be adjusted. Inside the simulation, beings, like us, would experience time as a sequence of events. But to an outside observer, the simulation's time could be sped up, slowed, paused, or even rerun. In such a scenario, the flow of time we feel would indeed be an illusion, created for the purpose of the simulation's narrative. It's a fantastical idea, bordering on science fiction, yet some serious thinkers have contemplated it. Whether or not we live in a simulation, it prompts us to reflect on how constructed our sense of time might be. After all, even within our universe, time is what clocks measure. We assign numbers to events and call that time. We never actually see time. We see change, we see clocks ticking, and infer time from that. In a deep sense, time might be a way of organizing our perceptions, rather than a thing that flows on its own. Some modern physicists are exploring models where time is an emergent property, not fundamental, but arising from something deeper. We touched on this with Ravelli's perspective. He suggested that what we experience as time could be akin to the surface of water, a useful concept at our scale that dissolves into more fundamental components when examined closely. To someone at the atomic scale, the notion of a smooth water surface disappears into bouncing molecules. Likewise, to someone at the Planck scale, perhaps our flowing time disappears into a complex tapestry of quantum events with no clear arrow or rhythm, until you zoom out enough for a kind of average flow, time as we know it, to appear. It's speculative, yes, but intriguingly bridges physics and philosophy. And it resonates a bit with teachings from Buddhism and other philosophies that say the present moment is all there is, that past and future are constructs of the mind. Maybe at the bedrock of reality there is just an eternal now, and everything we call time is our way of stringing together the changes we see into a coherent story. After wandering through these profound ideas, we might feel a bit unmoored. Is time a solid river, or just a mirage? Physics offers no simple answer. Time is at once one of the most measured quantities. We can measure time to extraordinary precision, and one of the least understood. What is clear is that our everyday notion of time only scratches the surface. Beneath the calm flow of seconds we know, time has layers and secrets. It warps with speed and gravity. It ties into the increase of entropy. It possibly emerges from a timeless quantum world, and it might not ultimately be fundamental at all. And yet here we are, living in time, unable to step outside of it. Whether it's an illusion, or a dimension, or a state of consciousness, time is the medium of our lives. Now, as we gently come to the end of our journey, let's return to the simple present moment. We have travelled from the beginning of time to the end of time, from the subatomic flickers to the sweep of galaxies. It's a lot to take in, but you don't need to hold it all in your mind. You can let it wash over you like a slow wave. Feel the quiet around you, the softness of now. After contemplating billions of years, and the possibility that time is an illusion, perhaps the most meaningful thing is that this moment is real to you. Real and irreplaceable. Regardless of what time truly is, this moment in which you exist is yours. Time feels mysterious because it is. It may be that our human brains will never fully grasp time's true nature, but that's all right. We can simply appreciate the wonder that is time. The fact that moments happen, that change happens, that we have memories and hopes. All these are gifts of the flow of time. We started with a paradox. Time feels real, yet physics says it might not be. How do we reconcile that? Maybe by realizing that we ourselves are participants in this mystery. We are time in a way. Our hearts beating, our thoughts moving, are all part of time's unfolding. If time is a tapestry, we are threads in it. If time is a story, we are characters within it, writing and reading simultaneously. So as you sit here now, breathe softly and release any worry about clocks and hours. Outside, the rain might be falling steadily, each drop making tiny ripples in a puddle. And above, the stars are wheeling slowly around the pole. All is in motion, yet it can feel perfectly still when we pay attention. This is the paradox of time in lived experience. Sometimes, by fully immersing ourselves in the present, we step out of the rush of time and find a pocket of eternity. A silent night can feel eternal, even as the minutes pass. In a sense, perhaps now is all we ever have, an eternal now that changes. We have journeyed far and wide through concepts tonight, but we end with something simple and comforting. You are here, in this moment, and everything is okay. Time's secrets can be perplexing, even dizzying, but they need not trouble you right now. The secret life of time, for all its cosmic grandeur and quantum strangeness, ultimately circles back to where we began, this moment, flowing gently into the next. We began by wondering if time is an illusion. Maybe it is, in some ultimate sense. But if so, it is a beautiful illusion, one we live and love within. We don't need to solve time to appreciate it. The ticking of the clock, the turning of the earth toward dawn, the rhythms of a heartbeat. These are the lullabies of existence. So let's drift here a while at the end of our exploration. Feel the comfort of time's gentle passage. Each second is like a soft footstep carrying you forward, effortlessly. There is no need to rush. Time will carry you. The past is a story we carry in our memories, the future a dream waiting to unfold. Right now, between the two, you can just be. Perhaps that is the ultimate secret, that in the heart of all time's mystery, the present moment is profoundly enough. Let the quiet of this realization soothe you. We have traveled the cosmos and shaken the hourglass of perception, and we return with a simple truth. Now is all we truly have. Embrace it tenderly. Time will go on in its secret way, but you are here now, breathing, safe and alive, a tiny part of this magnificent universe. In this stillness, feel the peace of surrendering to time's gentle flow. There's no need to hold or to hurry. Just float. Tonight, as the stars move imperceptibly overhead and the world turns, you can let yourself float down the stream of time like a leaf on a calm river. The journey will continue, but for now we come to a soft landing. May you find rest and wonder in equal measure. Time's story is still being written, and you are a beloved part of it, a quiet moment in time, forever unique. Sleep or ponder, or simply exist without burden. The secret life of time will carry on its gentle cadence, and you are free to glide along, one precious moment to the next, on and on into the tranquil night. All is well here in the flow of time.